Looks like we're live. Hello everyone and welcome to yet another recreational programming session. How about that? Let's make a little bit of an announcement and officially start the stream. Hello everyone. Welcome. So let's do the usual thing. I read a circle live on Twitch. And what are we doing today on Twitch, a television website? Today we are, believe it or not, recording sound from your microphone. Exactly, that's exactly what we're doing today. So I'm going to give the link where we're doing all that, http twitch.tv/sodding, and I'm going to ping everyone who's interested in being pinged, and there we go, the stream has officially started. So today we continue developing Musializer, which is music visualizer that we've been developing for quite some time. And let me show you how it looks like. So I'm going to go to Musializer and I'm going to start it up somewhere here, right? So the thing you can do, you can basically drag and drop some music and it starts visualizing things. Right, and then you can press F and it will try to produce like a high quality video of this entire thing, right? So that's basically what we have so far. So I released it actually crashed. Right, so I think there are some bugs in there, but anyway, so it's alpha. Okay, so it's an alpha, so it's totally fine for this thing to crash sometimes. So and essentially when I released that on Windows, right, so we did a Windows build, by the way, for anyone who's interested, for anyone who wants to use that on this niche operating system for video games, you can do that now. Right, so there is an alpha release. I'm going to copy paste it here to the chat, and for everyone who's watching on YouTube, potentially it's going to be in the description, right? So Windows alpha release 1. So, and when I released that, people started to suggest multiple times actually on different like social medias and stuff like that, why not just capture the sound not from a particular file that you drag and drop, but from, for example, speakers or from a microphone, and visualize that. That would have been actually kind of cool, because the visualization itself is actually kind of pretty, right? And you know, making it react to the environment, surrounding environment via a mic, I think it's an interesting idea. Right, and that's what I wanna research today. I don't really know how to do that yet. That's something that I wanna research. Right, Raylib itself does not really you know, enable you working with microphones or anything like that. So it actually implements like a bare minimum for video games. And in the video games, what do you want to do? You want to play music in the background. You want to play sounds, like a sound effects and stuff like that. And you want to apply different effects on the playing sound, right? And that's precisely what Raylib allows you to do. So and that's precisely what it exposes. I don't think it has anything to do with microphones. Yeah, so it, like, even microphone doesn't show up when you try to search for it. So that means we have to go a little bit lower in the layers of abstractions, and lower Raylib. We have a thing called miniaudio, and miniaudio is a header-only library for audio, right? So here it is. I'm going to copy paste it in the chat for anyone who's interested, and of course for YouTube it's going to be in the description. I already copy pasted it in there, if I'm not mistaken. Yeah, here we go. So it is an audio playback and capture library written in C in a single source file, right? It's a STB style single header library, right? So, and we already worked with those. And as far as I know, it's cross-platform, right? So it probably supports Windows and Linux and stuff like that, right? So does it say it's cross-platform or Windows? Yeah, so there we go. So at least it mentions different operating systems. Just compile, there is no need to install any dependency. On Windows and macOS, there is no need to link to anything. On Linux, just link to pthread mathematical library and DL. On BSD, just pthread. So it supports like so many operating systems: Windows, macOS, BSD, Linux, right? So if you use this entire thing, right, you can work with sound on all these operating systems, which is pretty convenient. So, and yeah, that's basically what I want to do today. I want to explore this library. I've never used this library before, only through Raylib, right? So I just used the sound functionality of Raylib, and that's how I used it indirectly, so to speak. Right, that's the plan for today. That's the plan for today. Let's go ahead and download this library, shall we? Let's go ahead and download this library. So if I go ahead, I think I can just like, does it have releases? Right, so there are some official releases. There's only 4 releases. Right, okay, apparently there's nothing in here. So you're supposed to probably download the latest one that is available in the repo. It's pretty huge. You know that the file is huge when it's a text file, and GitHub refuses to display it because it's too big. Yikes. Okay, so how big is it? How big is it? I suppose it's pretty... Okay, even browser cannot display it. Okay, let's not try to display it. Let's just go ahead and download it, right? Let's just go ahead and download it. I'm gonna go to probe, miniaudio. I'm gonna start like a separate small project in which I'm gonna be experimenting and stuff like that. I'm not gonna start integrating it into Musializer right away. I just want to explore that. So let's go ahead and wget this entire thing. And so yeah, let's download that. HTTP request sent, awaiting response. Excuse me? It's that fucking big that you can't even fucking download that. I might be doing something wrong. So let's try again, but you know, with passion. Let's press the button, you know, the famous button that GitHub added recently to download a raw file. 3.8 megabytes, holy shit. It's a text file. 3.8 megabytes. What the fuck? Finally we managed to download that. Anyway, Jesus Christ. So we're off to a great start, I must admit. We're off to a great start. So miniaudio, let's just copy it in here. So okay, how many? Oh, it's 100. Okay, so I thought it's like almost million. I'm just like, you know, had a brain fart. So it's 100K. Holy fucking shit. That's how we know that it is cross-platform. Right, that's how we know that it is cross-platform. Anyways, let's create a main.c, not cj, main.c, I said. And let's just include this entire thing. Right, and the way you're supposed to use this single header-only library is by just including them, right? So that's how you use them. You just do include, and you are good to go. So you can just go ahead and compile this entire thing, main.c, and boom, it compiled. In fact, it compiled very quickly because we didn't use a single function from this library, so the optimizer probably just stripped it away, right? And if I understand correctly, these kind of things, oh yeah, it's literally STB style, right? So it has this implementation macro that you have to define before including it. And what that means is that by default, this header acts like a header, right? And it contains only the declarations of the functions and declaration of the structures and variables potentially and stuff like that, but it doesn't have any implementations. So it acts like a header. So if you wanted to act like a C file, so meaning that it should include all the implementations of the functions and stuff like that, you have to explicitly say miniaudio implementation, and now it starts to act like C, right? And we can try to compile this entire thing, and it's taking some time to compile this. Right, and it could not compile because, as the documentation said, you have to link with all of this goodness like a pthread, DL, a mathematical library, and stuff like that. Right, let's actually quickly do that. Pthread, DL, LDL, I think you have to do it like this, right? So, and mathematical library, and it should finally compile. There you go. It's as simple as that. Chat says 3.8 megabyte, not so mini, by the way. But I mean, it's a single file. It's a single, it's not, I don't know, like we're living in an age of like terabytes of, you know, hard drives. Is 3.8 that much? Like, I mean, this is like a hello world in React in a single bundle, you know? So why file sizes like that are okay for JavaScript application, but when it's C, which provides, by the way, a huge value, this library provides an enormous value. It's sound, the most complicated thing in all of the operating system, and it supports all of the operating system in a single hello world of React. Just think about that. Right, it's all about perspective. Yeah, it is big, but for some reason JavaScript people don't give a shit about that. Right, for them it's just a hello world. It's just a single button on a screen that makes fart noises. We managed to cram so much, well, I mean the developers of miniaudio. By we I meant C community, right? So it's C community. We managed to cram into that space so much freaking value. It's insane. So yeah, it is big, but it's worth it. Trust me. You know what I'm talking about? You know what I'm talking about, chat? Come on. And yes, speaking of, your node modules folder is way bigger. It's usually gigabytes of data. That doesn't really do anything, right? Anyways, enough of that. Let's do some programming, shall we? So I think it would make sense to actually take this, command line and maybe put it in the build.sh or something like that. Right, so maybe I'm gonna do bin.sh and set xc. There we go. And I also want to make this entire scheiße executable. And boom, now I can build this stuff like this. We can measure how much time it takes to actually build this entire thing. So let's see. On my machine, of course, on your machine it's going to be way faster, right? Because you have a modern computer. I have a 10 years old laptop. And all of that without even including optimizations. So what if we included some optimizations, right? So it's probably going to take even longer. Look, it's only half of a minute. It's only 30 seconds. Can your Rust do that? Can you? I don't fucking think so. Building an entire project in only 30 seconds. Rust is blown the fuck away. Anyway, so so let's continue. So can we just have like a simple hello world example of miniaudio? Okay, so we have something interesting. Oh, you can just straight up play sounds. Wait. If playing just sound is easy like that, why do I need Raylib exactly for sounds? I mean, it's as simple as in Raylib. Like maybe I can ditch Raylib specifically for sounds, right? And use miniaudio directly. That sounds like an interesting idea. I mean, it's a little bit more convenient, right, to use Raylib, right? So essentially, I suppose Raylib was designed so you can go lower in a level at any point, right? So if you just don't need anything super fancy, you can just use that. But if you need something more complicated, it's super easy to go lower and start using miniaudio. So yes. Let's go ahead and just like go through this tutorial. So you're supposed to create this sort of variable. MA result. Oh, look at that. You can instantly see that the developer of miniaudio is a veteran C developer because they define all of their variables up front, like in old-fashioned C. Right. The old habits. Right, in the modern C, you can just define it in any place, but yeah. Or maybe this is a Fortran developer. Maybe this is a modern Fortran developer. Who knows? Because in Fortran still you have to define the variables at the beginning of the procedure or subroutine. So who knows? So first thing we have to do, we have to initialize an engine, and also we have to have the engine defined somewhere here. I wonder if you have to zero initialize it. I usually like to zero initialize this kind of thing, but I'm not sure if it's necessary. So we pass that engine to this thing, and the first argument is null, meaning that we're kind of ignoring it. But I'm curious, what is the first argument? So I'm really curious what it is. So let me find the definition. Okay, so Wait a second. Wait a second. Can I use Google to actually search within this entire thing? Right. So what if I do Google, Google, and just do like mini audio and search for a thing that's is called my engine. My engine. My engine. Can I find my engine? I found my engine. But yeah, it didn't really work the way I expected it to work, but I suppose I can say that this thing is supposed to return my engine. Right. Yeah. And also it should accept my engine. Well, I mean, it returns my result and my engine. I didn't have a need. Google sucks. Google freaking sucks, right? So I'll have to fix it somehow. Right, I cannot just find it by the definition or anything like that. So maybe I need to find my engine. It would be kind of cool if it searched only by the declarations. Yeah, there we go. So it's my engine config. It's my engine config, which I suppose is a structure. Right, and this is where I can configure everything. So I can have a logger, so this entire thing can log things. That's actually very convenient. So I can provide my own logger. I can provide like how many channels do I want, the sample rate and stuff like that. And I suppose if I don't provide the configuration, it uses the default configuration, right? So it just uses the default configuration. Okay, that's fine. Right, and this thing, if result is not equal to my success, what happened to my success? We just return -1. Like, who returns negative value out of the main function? Is that a thing? Is it like, because on Unix I only saw like just non-zero. Why does it have to be negative though? Why does it have to be negative? I don't freaking know. So anyway, so maybe we should just try to go ahead and compile it. And the last thing we are supposed to do, we have to uninitialize the engine, right? So let's just go ahead and uninitialize. So let's just build this thing. Now it seems to be working. If I try to run this entire thing, is it going to log? It didn't really log anything, right? It didn't really log anything. On Windows, it's common, I think. Oh, okay. So like, I don't really know the traditions of Windows, but I can imagine that maybe Windows does have some of such traditions. So let's actually take a look at this thing through a debugger. Let's compile with debug information. And stat gf main. Actually want to do that like this. And let's break on main and run it. And we probably want to watch on the engine, right? So engine is a structure. I'm pretty sure it is a structure. So it's supposed to be, well, it's going to be 0 initialized as we go through this line. Okay, so everything is 0 initialized, everything is fine. And if we just step once, yeah, everything is initialized. So we have, yeah, it picked up reasonable sample rate, right? So that's the sample rate it decided to pick for whatever reason. So listener count. So we have a bunch of listeners. Looks all right, right? So I didn't think anything particularly special. Right, so and then if we step through and it deinitialize this entire thing, everything seems to be fine. Okay, so that's pretty cool. The debugger demonstrated that everything is all right. So now what we have to do, we have to play the sound, right? So let's go ahead and play the sound. But what kind of sound can we play? So let me go to mini audio and find, okay, so you're supposed to provide the file path, but do you have to provide specifically wave sound? Can you provide something else? Can you provide OGG? Maybe, because like it's not really specified in here, like anywhere. And they also use Hungarian notation, so p file path or something. So anyway, I'm gonna go ahead and just like literally try to use OGG in here, right? So I'm gonna copy paste some of the sounds that I use for tasting. Musializer, music, null. So I probably want to go somewhere here, just another, yeah, there we go. So that's the thing I want to use in here, right? So that's the file, and we will see if it's going to complain or not. We may also want to maybe put that into sound file path, something like that, right? Sound file path. Just put it in here. There we go. So that's pretty cool. We don't have to actually say anything. Look, this one is interesting. You have to stop the application, like basically block the application with getChar, right? Because getChar is going to wait for the user input. That means that this thing is probably playing in a separate thread. So miniaudio apparently by default is multi-threaded. That's actually pretty cool, so I don't have to do anything about that, right? So I don't have to create threads or anything. It's actually very convenient. So, okay. So that probably means that we literally have to do the same thing as well, right? So press enter to quit. Also new line. Well, I mean, new line is not really necessary, right? So getChar. I'm not sure how it's going to work in Emacs. I think in Emacs it's going to work fine, right? Oh, yeah. So hence the p threads, right? So that's the reason why we linked with p threads, because otherwise we won't be able to do that. And generally, when you work with audio, you probably want to do that in separate threads, right? Because the audio should be playing as you interact with an application. So it's by definition multi-threaded, right? Sound by definition is multi-threaded. All right, seems to be cool. I'm gonna actually lower down the sound for you, just in case it's super loud, and I'm gonna go ahead and run this entire thing. It is not playing anything. Literally, it is not playing anything. So I suppose it doesn't support that. But I wonder if there is any way to maybe, you know, check that it couldn't load the file, right? There must be something. The function that we're calling, right, the engine play sound must return something. It should return a success, right? And if it probably didn't return success, we should say, well, I'm sorry, too bad, right? I wonder what I wanted to do. So I wanted to, yeah. So just find the definition of this function, right? So here, yeah, it already returns my result. So we can say result equal if result not equal my success. Oh, my success. We're gonna just return without even saying anything. So let's rebuild this entire thing. My success. I really like this. This is the best prefix you can even come up with, like ever come up with. my engine, my result, my success. Oh. Yeah, it just exited abnormally. But I was hoping that it's going to log something, right? I was hoping that it's going to log something, but this motherflipper didn't log anything. It's just like, bruh, I can't do that. Sorry. Ooh. Anyway, we can at least say something in here, right? So we can say fprintf std error could not load, could not play sound, and let's just like provide something like this. This is gonna be s, and this is a sound file path, and let's rebuild this entire thing, right? So it's not a complete example. They don't even say that it specifically have to be wait. I mean, it's still a good example. Don't get me wrong. It's still a good example. It's just like, here's the basic thing. That's how we do that, right? If you want more, read the fucking code, right? And that's exactly what we're doing. So I'm super happy. Yeah, could not play sound, blah, blah, blah. So I suppose what we have to do, we have to convert it to wave. Shouldn't be that hard, right? Shouldn't be that hard. So essentially what we have to do, we have to use ffmpeg magic. So let me actually maybe do it in TMP. So we have to provide this as an input, and the output is going to be, I suppose, sound wave. So this is going to be sound wave. I wonder if this is going to be enough. I think this should be enough, right? So because it knows that it's not an audio, right? It knows that it's not an audio, so hopefully it will just... I feel like you would have to say that no video, right? So don't... Maybe you even have to say no video for the output, right? So this is quite important, right? So since I put VN in here, it is applied to the output, not the input, right? Because I feel like I remember that if you didn't provide a VN for the output, it will literally try to produce a video and it will just call it a wave, but it's still going to be a video. We can give it a try, right? So because FFmpeg being silly like that, I do remember that. Right, FFmpeg absolutely loves being silly like that. Right, so it created wave. We can take a look at the file, and it's Reef. It's not that bad actually. So it's literally okay. I don't think it's. I think it's fine, right? Like I got burned by something like that some time ago. Oh, I think I was trying to extract an audio out of video and it still produced the video because I didn't say explicitly please no video or something like that. So yeah, so that should be fine. So if I do MPV, is it going to play something? Okay, so it seems to be playing. That's fine. All right, so let's go ahead and just do something like this. So this is going to be sound wave. Right, and let's just do build.sh. So MPV is playing everything. So let's see if this application is going to play that successfully. So this is going to be main. Okay, thank you very much. I already started, like I was about to epically start this project. We're gonna start again. Right, I really like when I just download the library, just follow the instructions, and they fucking work. I absolutely love it. Like, we need more software like that, please. Please. It's just like, you download the library, follow the instruction, and they fucking work. That's how it's supposed to be. I really fucking appreciate that. It's so rare in 2023, you won't believe how rare it is. And it's just a small single file. Small single file. So what's going to be the next thing? This example shows how to decode and play a sound using the low-level API. So this is a high-level API. There's a low-level API. So we're going lower in abstraction. So first we went from Raylib to miniaudio, and within miniaudio we're going even lower in the abstraction. Holy shit! Soon we're going to be programming in assembly, without operating system, without any drivers, like interacting with the hardware directly. Isn't that cool? Oh. Anyway, so what we have to do in here, so there's a data callback. Okay, so it's basically through a callback or something. And there is some sort of a decoder. My decoder. Read PCM frames from my decoder. So my result, my decoder. Okay. So we provide some sort of formats. We initialize the device and we start the device. Oh, this one is interesting. This one is interesting. But this is, I suppose, needed for some special formats, right? So essentially here you're decoding the format yourself, or maybe through their decoder, right? So apparently it is through their decoder, and then just sending it to the device. So that's basically what's going on in here. All right. You know what? I would like to jump directly to maybe capturing the sound, because that's what I'm interested in. I'm pretty sure there should be an example that captures the sound. So is there something like, oh, simple capture, okay, that's pretty cool. Demonstrates how to capture data from a microphone using low-level API. Okay. This example simply captures data from a default microphone until you press enter. The output is saved to a file specified on the command line. But this is actually pretty interesting. Which microphone is it going to use? Because I have at least 3 microphones attached to this machine. There is a built-in microphone for like in the laptop. There's a microphone like this one, and there's also a microphone in the webcam. Right, so there's at least 3 of them. So which one is it going to pick? And can we enforce a specific microphone? right? That would have been interesting, because in a Musializer, it would be kind of cool if the interface itself would have shown like all of the microphones that you have, like in sort of like in the front page, and you would literally just pick, okay, pick from that microphone or that microphone or that microphone, and don't depend on the default choice of operating system. That would have been cool, right? So yeah, this is something that we should do definitely. Okay, so from your default microphone until you press, the output is saved, blah blah blah. Capturing works in very similar way to playback. The only difference is the direction of data movement. Instead of the application sending data to the device will send data to the application. This example just writes the data received by the microphone straight to a WAV file. Okay, that is very poggers, meine Freunde. This is very poggers. So we have to initialize the encoder in a very specific form. This is so freaking cool. I love that. Right, so we initialize the encoder. Right, so this is the config file, my encoder init file. So there's like several factories initializing configuration and stuff like that. So device config, my device config init, device type capture, config format. So we initializing all of these things. Then we initializing the device. We're starting the device, we're waiting, and then we just finish in here. And then we save it to here. But that's unclear, like no output file. So where do we provide our v? Oh yeah, I see. So you provide the file. You provide the output file through the command line argument, and then you just do that. Okay, let me actually maybe copy paste this entire thing to a separate file, right? So I want to copy paste it to a separate file, right? Example.c. So I don't flashbang you constantly, right? So I do not flashbang you constantly, and we can slowly just go through this entire things. To be fair, it's rather interesting. If it's that simple, we can just go ahead and integrate it today on today's session, right? And that would be pretty cool, because the only thing you have to do, you just have to take these frames, right? So, and these are the frames, right? So this is basically the input, or maybe it's output or whatever, right? So take the frames that we've got and just send them to FFT Analyzer. And then it's gonna just visualize, because FFT Analyzer doesn't give a shit, right? So if you give it some samples and it will just visualize them. It doesn't care where they came from. So that should be pretty straightforward. And what's cool is that miniaudio comes with RayLib. So you can't access the RayLib declarations, but if you provide them and link with the RayLib, they will work. It will just use the RayLib from the miniaudio from RayLib, right? Because they baked into the RayLib. It's actually kind of cool, right? I suppose it's going to be the same as with STB, right? The same as with STB image and stuff like that. Okay, then. So let me see. Right, so we can call this something like play, right? So this is going to be the play example. So this is build, and we just create the play. So let's remove main. And now we probably want to create something like record. Record.c. I'm going to include miniaudio, audio.h, include fine, miniaudio implementation, and all right, I'm gonna return this kind of thing like so. Let's take a look at the example. So what I like to do with examples, I like to go through them, right? I could have just taken this example and compiled it and run it, but it's not particularly useful because I don't understand what the hell is going on within that example. I like to sort of re-implement that example, go through that example, and understand what each individual sort of part and line does. So then I can reuse the code, right? So if you can't look inside of the black box, you cannot use that black box in more interesting ways. You only can use it the way you were told to use it, right? So to find new ways of using the black box, you have to disassemble it and look what's inside of it. So you can take the insides of that black box and rearrange them to the way you need it. So that's why I like to look into the code and actually understand it. I know that's really frowned upon. In 2023, you are supposed to be, for some reason, dumb developer who just copy-pastes the code and, you know, calls it a day. For somehow it is viewed as being smart and effective. So it is like just taking some shit from the internet, copy-pasting it into your project without understanding what the fuck it does and calling it a day somehow is considered smart and effective. Like the world is fucking going insane. Like I don't understand this mentality. Like you are giving away control of what the fuck is going on in your project. Completely. You're giving away control. Like you do not control situation whatsoever, and somehow you are the smart one. I have no idea how does that make any fucking sense. So how are you smart if you are not in control of what the fuck is going on? You're by definition not smart. You're by definition whatever. So it's just like I don't understand how that makes sense. It's so weird to me. Anyway, and they're making up some very fucking dumb excuses like you can know everything in the world. How can you learn everything? It's too complicated. Well, and that's the reason to not learn anything at all. It's just like, what? And it's not about like knowing a lot of things, and it's not about memorizing a lot of things. It's about in control of the situations. And all of these motherfuckers are talking about aligning AI. Right. They're so obsessed with aligning AIs, but they're then giving away control of their source code to some random piece of code on the internet. It's just like, what the fuck is... Anyway, I need to stop ranting. I'm sorry. Anyway, let's go ahead and just like copy paste this piece of code without trying to understand what this piece of code does, because fuck that, we're being efficient. So anyways, so the thing I want to do actually, I want to copy paste this piece of code and try to compile it and see where it fails. Right, I'm gonna go ahead and just like do it like this. So this is a record, and okay, mini audio. You're supposed to do it like that, right? Audio. There we go. So it's doing something. It is doing something. Okay, so this motherflipper just compiled, right? So this motherflipper just compiled. Very interesting. Very interesting. Okay, so mini audio. So encoding format, ma format. So there is encoding format and just format. Very interesting. And then there is the channels and there is a sample rate. Okay, so we can try to take a look at what is encoding format. I suppose it's more of a something. Yeah, encoding. Oh, okay. Very interesting. So yeah, so it's basically we're creating an encoding for a very specific sort of like a container or whatnot, or not container, but yeah, you know what I mean. So the format is what? And the format is the format of the sample. U8, S16, S24, and so on and so forth. All right, so okay, so everything makes sense to me, right? So this is configuration. So we're creating a WAV file with float32 format. We have 2 channels, and this is the sample rate. So that's basically what's going on here, and we just created documentation for that specifically. Right. So that's very cool. That's very cool. So what next? What's next do we have? So then, based on that configuration, we are initializing file. Right. I'm not going to accept the file through the command line arguments, right? Because I couldn't care about that. So let's say output wave. right, output wave, and then I'm passing this encoder configuration that contains like what we want from the file. We want a wave file with a format float32, which I suppose from -1 to 1, and 2 channels. I'm not really sure if we need 2 channels, but I mean we can have them nonetheless. So we just give it as a pointer, and then we are given an encoder, and I suppose encoder is an output argument of this function, right? It basically creates an encoder. Yeah, there we go. So it just creates this specific encoder. All right, that is very interesting. And it can fail, of course. It can fail. So because of that, we're checking whether it's mass success. If it's not mass success, we say that we failed to initialize output file. Okay, all of that makes a lot of sense. I really like that. All of that makes a lot of sense. So if this thing not equal to mass success, we have to say fprintf failed. We can even have something like const char output file path, and we can just save this entire thing to there, output file path. So here it is, and we can say std error could not initialize as output file path, and then we're gonna return -1, right, because the tutorial tells us to return -1. Right. So do we need to do anything else? Do we need to do anything else? Actually, we need to take a look at the encoder init file. So just to see where is this function. Okay, so just encoder configuration. You can't really see that, but yeah, there we go. It's kind of interesting. Why do we pass configuration by a pointer? This is just a structure, and by immutable. So that means we do not plan to modify it. We do not plan to modify it. Is it some sort of a big structure? And it's actually a really small structure. Right. If we, yeah, that's interesting. If we just passed it by a value, right, if we just passed it by a value, we could have simply just inline the whole thing in here. So the only reason why we have to have like this intermediate variable is because we pass it by a pointer, and so we cannot just do it like that. But I mean, it doesn't look good anyway, so I guess it's fine. It's kind of interesting because modern C developers are not afraid of passing structures by a value, because this is something that the modern C compilers can do. Oh, wait a second. Defining variables at the beginning of the function and also passing structures by a pointer, even constant ones. How old is the developer of miniaudio? Like, I'm really curious. Their code looks like a code of a veteran C developer. Right, it's a very old-fashioned C development style, and I'm not criticizing it, by the way. I'm just curious. It's because it really feels old-fashioned. Right. So, but maybe it's not necessarily the developer is old-fashioned. Maybe is that they target very specific platforms like C89, right? So maybe this library is trying to be so cross-platform, it supports some places where there's only C89 compiler or something like that. Maybe it's supposed to also work in embedded. Who knows? Yeah, maybe. So you know what's interesting about the code that works for embedded? If the code doesn't contain anything like low-level platform specific, that code is probably going to work literally everywhere. Like literally anywhere it will work, right? If it doesn't call to some like very specific exotic assembly instructions or anything like that, it will literally work anywhere. Literally, yes, literally. Thank you, chat. 3.2 megabyte in embedded, but this is only a file size. This is just text. But if you compile it with special maybe macros, so the thing about header-only libraries, by the way, is that they usually implement shit ton of macros that allow you to literally disable chunks of the library, the chunks that you usually don't need. So STB library, for instance, it may have a macro something like no stdio, And if you define like no stdio, it will literally strip away any calls to printf and even including stdio or anything like that entirely from the library. So you usually with this kind of header-only libraries, you can control how much of the library you can include in your final binary. Right. So just because the full source code weighs 3 megabytes, it doesn't mean that it's going to weigh like that in a final program. Right. So because maybe there's a lot of macros and stuff like that. You know what I mean? Okay, good. Okay, good. So let's go back to the example. Everything is clear so far. So we created the encoder and the file, the output file, and now we have to create a device. So this is config init device type capture. All right. So let's go ahead and just do it like that. So this is not what I wanted, honestly. I wanted to copy paste this entire line, right? But I want to take the definition of my device config, right? So this is the device config. So this is example. Maybe I want to, nah, it's fine. And we are supposed to just set, oh, this is interesting, right? So what we're doing here, we are picking a capture device which has the same format as the encoder we created, right? So we take a look at the format, the amount of channels, the sample rate, and another thing we have to set up for the device is the callback, right? So which is probably a function, right? And we set the encoder as the user data. This is the thing I was complaining about in RayLeap. Right, because having this user data that is passed along the callbacks is a super common thing, right? It is a super common thing. I suppose it's passed, I didn't really know where it's passed, but I mean, yeah. Oh, it's passed as the device, right? It's super common thing, and RayLeap lacks that for some reason. And if you want to pass some custom data to a callback, you must pass it via a global variable. You're kind of forced to do that. And I don't know if that's by design. It could be by design, actually. It could be by design. But the usual convention is just like you have this like extra parameter that the caller of the callback passes to you. Because C doesn't really have like closures or anything like that. So you can't really enclose your environment and keep it with you. And by the way, closures are basically that. Closures are basically that. So you basically say, like you take the data that you want to, you know, capture with your function and you keep it there. It's just like all the function languages just do that for you automatically, somehow. They also try to, you know, hide the implementation details of how it's done from you. So in C, you have control on how you pass information in your closure, so to speak. Yeah, I'm drinking cup of air, right? So just a second. Cup of air. Yes. Are you jealous? Are you jealous that I can sustain myself on just air? All of you need coffee and tea and a lot of caffeine. I can sustain myself on just fucking air. Yes. Eat that. Drinking Siberian air. Yes, exactly. Anyway, who needs tea? Who needs tea if you have air? Okay, good. I want to take a look at the function that initializes the device and stuff like that. Mini audio. Because I want to, yeah, there we go. I want to take a look at my device type. So, and there is apparently 4 kinds of devices: playback, capture, duplex, and loopback. And duplex is basically playback and capture, which is 3. Holy shit, this is so fucking clever. Do you guys fucking see that? Do you see what they did? Do you freaking see what they did? Okay, so this is enumeration. Like, holy shit. This is enumeration, right? So it means the value go like, you know, in increasing order, right? In an ascending order. If you take a look at the binary representations of 1, 2, 3, and 4, right? So 1 is 0, 1, 2 is 1, 0, 3 is 1, 1, and 4 is 1, 0, 0, right? So essentially we probably want to do something like that. So that's basically what we have. And essentially, bits represent what kind of functionality is enabled, right? So the first bit in here means that it's a playback. The second bit means it's a capture. Both of them together means duplex, both playback and capture. And it's naturally placed in a place 3. So it naturally both of the bits. But not only that, they could have just put 3 in here, but they explicitly define it as or between 1 and 2 to actually document, to actually tell you, yes, that is intentional. They not only just did it like that, if they just did it like that, you wouldn't even know that that's the intention. But by doing it like that, it's self-documented. The intention is self-documented. Holy fucking shit. Like, I'm looking at the code of miniaudio. This is such an experienced C developer. This is such an experienced C developer. Like, they know how to just describe intentions as the code, right? Because the junior developers, they document with comments, just with comments. But this person, the authors of miniaudio, they know how to document with the code itself. Compliments from Zozin. I really like that. Right? I like this library so far. Right, I really like this library so far. Junior devs don't document at all. What are you talking about? Juniors write more comments than they write code because that's what they teach them in the university. These motherflippers in the universities literally tell them you have to document each individual line somehow. They tell them that you write a code and you literally need to duplicate that code with natural language for whatever fucking crazy reason. Like, I have no idea why they tell them to do that. So it's so pointless and useless and actually clutters the code. It's like, why people do that? So just like this, for example. I'm joking, by the way. So it's probably it's probably correspondence to. Oh, it's correspondence to the numerations and stuff like that. Oh yeah, you start with UML diagrams, exactly. Yeah, I forgot about that. I don't remember how to program. I'm sorry. Okay, we created the device. Specifically, we created a capture device, not the duplex one, right? But a capture device. Isn't that a poggers? Isn't that a woggers? Isn't that a woggy poggers? So I would like to take a look at the structure my device config. Okay, it's not a structure apparently. My device config. I haven't. Yeah, what I have to do, I have to create. Am I going crazy, chat? I feel like I'm going crazy. My device config. Why can't I find this thing? Ah, because I see what's going on. Because they decided for whatever reason to have type def separated from the structure definition. Sure, I mean, fine. I don't judge. My device config. So there is a device type. Okay, so we know what is device type. There's 4 device types. Sample rate, period size in frames, period size in milliseconds, my performance profile. Okay, there's a lot of things that document actually. That's actually pretty cool. So there's a callback. Oh, and the definition of playback and capture is actually inside of the definition in here. That's good actually, because I was looking through the example and I saw that there is like one layer of indirection. So I thought that we'll have to jump in a different place to just see the definition of this thing, but I actually don't have to. WhatsApp. Wait. What is WhatsApp? I don't really know what is WhatsApp. Is it related to WASI? Maybe it's not. It's probably not related to WASI. But anyway, so there's also Pulse, Core Audio, A Audio, and stuff like that. Okay. Everything seems to be okay. Everything seems to be doki a karaoke. So I'm happy to continue with this stuff. So we just set the format and the channels the same as for the encoder, right? And of course, we set the same sample rate. And then we have to set the data callback and the user data, and we set the user data as the encoder. And the encoder is, I suppose, my encoder config. But in the example, when we do the device, oh, we pass the device through. Okay, I see. So that's how we extract this entire thing. So the encoder is, all right, that makes a lot of sense. And of course, we have to initialize the device, right? So we must initialize the device. That's pretty cool. After we configured everything, failed to initialize capture device. So it's -2. We're indicating like different errors. Ooh, this is actually pretty cool. Yeah, so we know where exactly it failed, right? We know where exactly it failed. And then we're just starting the device. But if we couldn't start, we have to uninitialize the device anyway, right? So that's quite important. I see what's going on. All right, so that seems to be fine. And then we're just starting to record. And then we're uninitializing all of these things. Okay, so everything is clear so far. I really like that. So I didn't look at the definition of these functions because they just accept the parameters, right? They don't really accept anything else. Right, so I guess it's fine. So null in here is probably just like an additional thing. We already saw that before. Okay, so and in an example, right? In an example, we accept the data parameters. I'm not really sure what is input and output. Oh, I think I know what it is. Yeah, so essentially it's a general data callback for any kind of device, right? So if it's a capturing device, you would receive something in the P input. If it's a playback device, you will have to write into P audio, P output, right? So it's basically like a general callback for any kind of device, both playback and capture. Makes sense to me. So that's probably why it is like that. That's probably why it is like, and this is exactly what they do in here. They literally explicitly ignore P output. Okay, so I really like this. I really like working with this code. It's just like it's so beautiful, right? So like I have a question. It's super easy to answer any questions, right? Yeah, it all makes sense. Everything makes sense. Everything makes sense. I'm super happy. Like it's so pleasant to work with a code written by a competent person. It's just like so good. Love it. All right, so let's try to compile. All right. So we have encoder, a redefinition of encoder config. Oh, this is because I copy pasted something very stupid. So let's go through the rest of the compilation errors. What else do we have in here? An encoder. Oh, I suppose what I meant to define in here is an encoder, right? So I want you to define an encoder. Can I just like do it my encoder? Is that just my encoder? Right. Yeah, it's just my encoder, so I can just do it like that. All right. So what else do we have? So this is the result. This is the first instance of my result, so we have to define it. So what's the device? And we never defined the device, right? So I suppose it has to be my device. My device. I don't even have to look up through the example anymore because I understand what the code does. Right, so I can just fix all of that stuff. Right, that's the importance of understanding the code, right? So once you understand what the fuck is going on, you can just work with that and you can sort of shape it in whatever you want. Alrighty, so we've got some stuff. And I wonder how can we use that. So what is the default microphone? I wonder if several programs can use my mic simultaneously, because currently OBS uses my microphone. What if it's going to be a second application that uses my microphone? I think it is a thing on Pulse Audio, right? And if I remember correctly, this mic is set as the default one, right? So that's why OBS picks it up quite easily all the time. So let's try to record something, I suppose. So record. Oh, no protest. Okay. So all right. So let's actually listen to what the fuck is going on. Easy peasy lemon squeezy. So we managed to actually capture some shit from the microphone that easy. That's pretty cool. All right. I mean, we can just already try to integrate this entire thing with Musializer. I think it should be pretty doable, right? So it's just like we have to initialize just the device. We don't have to initialize the encoder, right? Only the device. And right, and receive stuff from that specific device. But that means we should not use the RayLeap stuff, right? So we need to have two separate, well, even from the point of view of UI, naturally we want to have two separate modes in Musializer, right? The mode that plays the music, right? So let me actually start Musializer so we can see what the fuck am I talking about. So this is Musializer, this is going to be OPT RayLeap environment. And I'm going to put it like that. There we go. So in Musializer, there is right now only like one mode where you can put some music in here, right, and it's playing the music. But I suppose there should be two modes. When you drag and drop a file, it goes into this mode, and maybe there should be a button. When I press it, it uses your mic to actually record shit. So yeah, and when you're doing that, we're using a completely different callback. Okay, I can already see how we need to shape the code of Musializer to actually make it work. I think it's doable. I actually think it's doable. All right. So, and an interesting thing is going to be, so you need to be able to record your voice, or maybe not only your voice, but from your mic before you can actually render it. So from the UX point of view, we need to establish sort of the protocol. How do you generate videos from what you just recorded? Press M to use mic. Yeah, that's actually a pretty good idea. So some sort of a key would be good maybe, but we'll see. I also want to have like a pretty cool UI, like material UI with flat buttons, like we did with Tic-Tac-Toe and stuff like that. That would have been cool. Yeah. So we need to establish some sort of like a UX protocol where you are in a record mode. Then you press a special button, maybe key, maybe button, and you record for some period of time. And then it takes the sample that it recorded and goes back into playing music mode, but with the sample it recorded. So then you can continue as usual by rendering the video out of what you recorded. That's actually a pretty cool idea, right? So we can reuse already existing state machine of UI to integrate the, the microphone stuff. Right, with the microphone, you just record some stuff, and while you're recording, of course, the visualization is going to work, right? So while you're recording, Visualizer also shows how it's going to look like, and then it sends it back to the state where it feels like the recorded thing is basically the file that you drag and dropped. Right. So that's basically the idea. That's basically the idea. So yeah, let's try to do that, but we're going to try to do that after a small break because I ran out of air. So I need to refill my cup of air. And after I have my cup of air, we're going to try to integrate that with Musializer. All right, so I'm back. Let's go ahead and try to integrate this entire stuff into the Musializer, right? So as I already said, the Musializer should already contain mini audio implementation. So the only thing it needs is mini audio declarations. So one of the things we can do, we probably want to go and just copy paste. just copy paste the mini audio header. So what is this mini audio? There we go. So here it is. And I'm just gonna casually copy paste this entire thing. So look, if you do the usual define mini audio implementation and just include mini audio like that, you're gonna be slapped in the face immediately, like immediately. I'm telling you, So look. Right, so just build, we have to build POSIX, yeah, there we go. So we're gonna get slapped in the face, I'm pretty sure we're gonna get slapped in the face. We didn't get slapped in the face, that's really bizarre. Why can't you just slap me in the face, please? Anyway, so one of the things we can try to do, we can try to maybe initialize the encoder, right? So let's just go ahead and try to initialize the encoder, because I'm pretty sure the optimizer just like stripped all of that away, so that was totally fine. But if I try to do it like that, I'm pretty sure it's not gonna work. So there's an unused variable. That is bizarre. So usually it worked with STB image library, right? I do remember that. So let me try to replicate that. So raylib, and when we're linking with raylib, yeah, we do link at the end of the day with raylib. All right. So I'm gonna go to nothings and I'm gonna try to find STB image. Runtime. Ooh, this is a good point. Maybe it is runtime, maybe it is loaded at runtime. But I mean, the code that loads this thing at runtime still can collide at linking stage, so I'm not quite sure. Right, but I had a similar problem with STB image. So I want to try to replicate that problem for scientific purposes, right? Because we want to understand what the hell is going on. Just give me the row thing. And I'm gonna just download it in here. So because raylib also includes STB image, right? Its own STB image. Oh, its own instance of STB image, I would even say. So STB image implementation STB image.h, and let's just try to do that. Right. So it's totally fine. Because again, we didn't use any of that. So if I put it like that, and then STB image load, STB I load a thing, we can just copy paste this stuff and put it in here like so. And file name, let's just put something like image PNG. It doesn't really have to exist at compile time. What it has to do, it has to be like sort of a working code at compile time. And why does it work? I'm actually genuinely surprised. How does it work? Because I remember linking with raylib and STB stuff would collide with it. I do remember that. Do you guys remember? Because there was thing like that, but I can't reproduce that anymore. Surprisingly. So that is totally bizarre. Because if we take a look at the like raylib implementations, right? So there is the external stuff, and there is stb image.h. So here it is, stb.image, and then mini audio, any audio and stuff like that. So that is bizarre. So static versus dynamic, maybe. Oh yes, that's right. Thank you so much. I just remembered that I compiled raylib dynamically. God damn. Yeah. And the reason why I compiled raylib dynamically is because I'm using hot reloading. That's right, I'm using hot reloading. And essentially the executable and the library that I'm hot reloading, they use the same raylib. And to achieve that, you have to have raylib in DLL. Yeah. So thank you so much, chat. Right, I completely forgot about that. Right? So that's why it works. That's why it works. But we can still try to reproduce the situation if we compile for Windows, because for Windows we're still using static raylib, right? Because I didn't implement hot reloading for Windows. So if I go ahead and just like compile it for Windows, I mean GW, it should collide. Please. There we go. Finally, that's what you see. I'm not insane. I'm not insane. It actually does collide with STB image, right? I didn't confabulate all of that shit. I like, trust me, I'm not insane. Anyways, which actually raises an interesting question. Which function is it going to use? Which function is it going to use? Is it going to use the raylibs functions, or is it going to use our own function that we supplied ourselves? That's a very dangerous thing, actually. So, yeah, because in case of raylib, it could be dangerous. Raylib has global state, and if you have two instances of raylib, so like it's unclear which instance is sort of used. Does mean miniaudio has a similar situation? Does miniaudio has a global state? We have to be careful with this kind of stuff. I'm telling you, you have to be careful. So let's actually try to reproduce that with specifically miniaudio, right? So I'm going to do miniaudio, and I'm going to just try to do it like that, and I'm going to try to recompile with Windows, right? And on Windows it should actually fail. Ooh, on Windows it's complaining. Ooh, there is a redeclaration of rectangle because miniaudio, goddamn miniaudio, includes Windows, right? Yeah. I mean, what we can do, we can just not include Windows ourselves. Can we? I suppose we can just do it like that. Yeah, so there is a very annoying thing, is that some of the names in raylib collide with the names in Windows, and it's just like, bruh, how do I get rid of that? So it's not that easy. Specifically rectangle, because raylib defines its own rectangle. And if you try to use raylib and Windows, it's a little bit of a pain in the ass. And this is because raylib doesn't have any prefixes. Because the library is Chad like that, you don't need anything but raylib. Windows, GDI, no, the only thing you need is raylib. The only thing you need is a raylib. I wonder if there is any way to easily solve that. I actually wonder. Right, so there we go. So things like rectangle, right? So WinGDI, there is a rectangle, function rectangle. And in raylib, if we go to raylib, include raylib rectangle, there is a structure rectangle, and they collide with each other. And I don't think there is a, I don't see obvious mechanism of how to solve that. We can try to Google it up. Raylib Windows Windows H show cursor rectangle. So I'm pretty sure that was already, yeah. So because it's so obvious that this kind of stuff will happen. So I wonder what's the discussion in here. It would break too many things. Okay. As you mentioned, these changes are breaking the API in ways that would require changes already. Okay. Just for completion of the discussion, here's 3 options to avoid conflicts. Let's all of them and they work. Define and required symbols from Windows H instead of included full header. That may work. One of the things I did, by the way, when I was integrating Windows FFmpeg with raylib logging, right? So here is the Windows implementation of FFmpeg, and in case of an error, I was just using raylib logging. What I did an opposite thing. I copy-pasted all of the login related things from raylib, right? Because it was just easier. So, but maybe this is something that we can do in here, right? just it can do in here. But in case of mini audio, it's not really gonna work very easily. Compile Windows H with function using it on independent module called units. Okay, so that could be also a thing. Try avoiding with Windows.h. You know what would be cool? If there was some sort of a mechanism to add prefixes to the raylib functions. Essentially, by default, all of the names don't have prefixes, right? And if you define some sort of a macro, so maybe all of the names are wrapped into, you know, prefix, right? So all of the names are wrapped with this kind of thing. And if you define some sort of a macro, it defines prefix as name, custom name. You know what I mean? So essentially, the user of raylib can, well, that means you have to recompile raylib, right? You have to recompile raylib. But I mean, you can customize the allocator of raylib by recompiling raylib. So one of the ways to customize things would be maybe you just compile your own instance of raylib that just uses that. But I mean, there's also functions that call to things without the prefix, so it's not going to work, right? So this also not going to. It is genuinely difficult problem. It is genuinely difficult problem. So I can see that somebody in the chat said you can define no GDI. We can try that. We can try that. All right. So can we just define no GDI? But I mean, it may collide with something else. Right, so close windows. For example, how can I... Yeah. So we still collide with a lot of things in here. We still collide with a lot of things. So that is genuinely difficult problem. One of the things I see is maybe copy paste some of the definition that we use in here. Or I don't even know, man. We can try to keep like initialization in a separate translation unit. And just call to that. Yeah, we'll have to do that. But in any case, my point is, like what I want you to demonstrate is that when you manage to compile it, this name is still gonna collide with the name within the raylib. It's still going to collide within the name within the raylib. So I literally don't see any other way except like having a separate translation unit. So let's create separate translation unit for miniaudio.h, right? So we're gonna have this kind of thing. This is a separate translation unit for mini audio. And the thing I want to do in here, I just want to have the inclusion guard, right? Because the reason why I call it like that, because it's literally a hack specifically for this kind of situation, right? Since it's a hack, it has to be loud. It has to be extremely loud. So what we can do in here when we are initializing the config and stuff like that. So, so separate translation unit, init audio devices. So that's what we're doing here. And inside of this thing, so separate translation unit, C, when we initialize audio devices, right? When we initialize audio devices, right, we include mini audio, right? We include mini audio.h and simply do this thing in here. All right, but to make sense of this entire stuff, we probably want to have this as a global variable, right? So because it share the state between several functions that we may have in here. And that's about it. All right, so that's about it. And if I try to compile this entire thing, it will compile, right? But we have to move this entire thing out of here, right? So we already have it in here, but whatever. There we go. So, and it compiles. But now what we have to do, we have to call to init audio devices like so. Can you just like do it like that? Thank you so much. It doesn't have that thing, so that means during the compilation for Windows specifically, we have to link with this entire thing, right? So separate, blah, 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 there we go. So, and it's gonna fail now with a different problem. It's going to fail with a different problem. Well, it's gonna take some time. Yes, multiple definitions of mini audio. Right. So one of the definitions are coming from librelib. So the way you solve this kind of collision is basically by not defining mini audio implementation, and that's one of the important things, one of the valuable things that header-only libraries provide, right? Because sometimes you don't want them to act like C code. You want them to act like headers, because the implementations are already available somewhere else where you link with, right? We already have implementations inside of raylib, and because of that, we don't need miniaudio H to act like C. We need to act it just like a header, and that means you can include it as a header, and that should work. That should compile. Right, this thing complains that we have implicit declaration, but essentially what we have to do, we have to include separate. Can you just do separate that? So that's what we have to include. And it's going to be totally fine. Right. And it also should work for POSIX. Undefined reference, because for POSIX we don't really link with this kind of stuff. Where is that thing? Where is that thing? So hot reloading. Yeah. So let's put src separate.c. Undefined reference. Still undefined reference. Are you serious? Oh, this is because, yeah, you have to do that in both with hot reloading and without the hot reloading. So that's basically. There we go. So, and it works here as well. But again, since raylib in our case is DLL, if we define, what is it called? Mini audio implementation, right? Mini audio implementation, it will still work. But that raises the question, what mini audio implementations are we using? Are we using the ones from here, or are we using the ones from raylib? And what kind of problems does that introduce? And that's a genuine question, like, what exactly is going on? I don't know. So in case of, I think in all of the cases, regardless of anything, we don't want to include mini audio implementations because they come with raylib. So I suppose if we don't include implementation, it's going to just use whatever comes from raylib. Right? So I think it's safe to assume it like that. I think it is safe to assume it like that. All right, so that means we need to do all of this audio initialization inside of separate units so we don't collide with raylib. But if something goes wrong with these initializations and stuff like that, I still want to be able to log with the raylib logging, so we'll have to do the same trick as with Windows, where I had to copy paste login related stuff in here. So yeah, okay. It is a hard problem, and raylib is already used a lot in different places, so you can't just rename things. You can't just rename things. Okay, so let's just continue working on this thing. So we just initialize, we don't even have to initialize the encoder, right? So encoder is needed specifically if we want to record all of that stuff into the file, right? So it's only needed for that. What we need, in fact, we need to initialize the device, right? So we need to initialize the device. We need to initialize the device. So let's just create device config. So then the device, and then we do device stat, and that's basically what we need in here, right? So that's basically what we need. So init audio devices, we may return a thing that just keeps track of the device. In fact, we can return the device, my device, like a pointer to the my device. Oh, and by the way, since we passing device config by a pointer, does it have to exist the entire time? Damn, that's a very interesting question. What if what this function does, it saves the pointer to device's config and stores it somewhere? So, well, that can't be true. Like, it must just copy some stuff from there, like, we need to know that. That's a very interesting question. Like, it's a very important question, I would even say. So that's why I don't like passing like structures by pointer, because you can never tell, like, does it pass it inside of it or does it not? Like, you literally have to go and just like check the source code. You don't know what to expect from all of these things. Okay, so pconfig, what does it do with, okay, so there's this thing. So there is extended initialization, right, and with the context config. So pconfig, yeah, you may not provide it. Okay, I don't think it stores it, so it just looks into the devices. Yeah, that wouldn't not make sense, right? So that would not make sense. So I think it doesn't copy it. I'm being a little bit too paranoid about that. So separate translation unit for mini audio. So, and essentially because of that, that means we probably want to do something like malloc size of my device, and of course we probably want to just assert that this thing, not equal to 0, not equal to null, I mean, by more RAM, lol, as usual. So, and here we're logging with printf for now, so that's fine. We're just initializing the device, but I suppose we should not start the device as of right now, right? So let's not start anything. So in the user data is rather interesting. So I'm going to keep the user data as null. So we're not going to pass anything anything there. So let's just return the device, and in case of an error we return null. And in the header, we're going to be returning void star to avoid requirement of knowing the structures and stuff like that, right? So we don't really want to know that. We don't really care about any of that stuff. And the question is how we're going to supply the callback. How are we going to supply the callback? We can try to supply the callback in here like that, but that requires knowing the mini audio stuff. So that means it has to be some sort of a different callback. It has to be some sort of a different callback. And I feel like maybe it should be callback similar to whatever we use in plag.c. Right, so there's a callback that just, yeah, something like this. It just accepts a buffer data and frames, and we just forward that callback like this. So we can, yeah, essentially we could reuse literally the same callback in plug. This is a genius freaking idea. Yes. Okay. Can I just do it like that then? So here is a separate unit, and we're gonna just literally do it like this. So this is a callback. Is that how you do that? I think this is how we do that, right? So, and then I can copy paste it back to C, right? And essentially, this is the user callback. This is the user callback. And we're gonna use that user callback as the user data, because in the data callback, we're gonna be adapting the data callback to the user callback. Yuzu. This is fucking genius, man. Okay, so we're getting somewhere. Chat. I really fucking like that, mate. I really fucking like that. So now, essentially, what we have to do, we have to take p encoder, right? So then p encoder, it's not a p encoder. It's a user callback. But for the user callback, we need to know its type, right? So which is not particularly convenient. So that means in here, we need to define like a type def. So let's define something like type def. So this is the user callback, right? So user callback. Is that a good idea? We might as well actually do that without the pointer, which means that maybe we should actually put underscore t. Did you guys know that POSIX reserved underscore t for its own internal things, and something bad's gonna happen if I name custom variable with underscore t? Oh my god! Sorry. Yeah, I should call it user callback t, user callback to underscore t. That's right. So that's the best way to call it, actually. Oh yeah, I'm gonna literally call it like that. Like, I don't care. This is gonna be literally the name of this thing. User callback to underscore t. Maybe I'm gonna even prefix it with double underscoring here. No, t2 is not that, right? It specifically has to be underscore t. It specifically has to be underscore t. I think this one is too much. Let's actually keep it like user callback to. Right, that's perfect. So this is a user callback, and if I go inside in here, right, so this is gonna be that, a boom. So we probably also have to include this kind of thing, separate.h, translation unit for mini audio. Okay, so and in here we use the user callback. So it's a pointer to the user callback. So user callback to t. So this is the user data. There we go. And we also need to double check that this scheisse is not null, just in case. And what we do is just, we call that callback. So the frames are going to be p input, right? So that's the p input, and the frame counts is that. There we go. So surprisingly, this thing is not const, which is a little bit worrying, not gonna lie. It is a little bit worrying, but we're not planning to modify any of that. So yeah, we probably will have to force this thing to work like this, right? So we'll have to do something like this. But we'll see. Otherwise, we just don't have any other choice, right? So we don't have any other choice. Okay, let's go ahead and just compile everything with POSIX and go to the compilation errors. Ma-assert. There's no ma-assert. Implicit declaration. Really? Is ma-assert only available if you define mini audio implementation? I mean, fuck you, Leatherman. Fuck you, I can just do assert. Fuck you. It's not a problem for me whatsoever. User callback p input, yeah, exactly. So this is cast void star, and to parameter void star, it doesn't really work that easily because fuck me. So yeah, that's basically the thing in software. If you wanna, if in open source software and software general, to be fair, if you wanna be able to say fuck you to something, be ready that that something is gonna tell you fuck you back. So because of that, we have to cast it explicitly towards star. There's nothing else we can do in this particular case because fuck me. So yeah, it is what it is, and it isn't what it isn't. It's the most valuable software lesson I can teach you, right? So if you want to say fuck you to something, be ready that that something is going to tell you fuck you back. So it is what it is, and it isn't what it isn't. But I'm gonna defend my right to say fuck you, even at the cost of being said fuck you back. I think it's worth it. I think it's worth it. Anyways, right. So init audio. So what do we have in here? So it's complaining about something. Conflicted types. It's just conflicting types because that thing returns void. I can return void as well in here. Who cares? What else do we have in here? Okay, so we were creating devices with the same encoding format as the encoder, but we don't have encoder anymore. We don't fucking have encoder anymore, my friend, so we have to explicitly define the format, the channels, and everything else. We have to do that. We have no choice. So let's go to here, and we can just like put whatever we defined there, right? So because what is the format? I think it was just, yeah, format is F32, I think. Yeah, that's the format. The channels, we have 2 channels, and the sample rate is 44100, right? So the classical thing, because that's the thing we have in here. So here it is. That's the sample rate. It's how many samples per second we have in our audio, and that should be it. I think that should be it. So is it gonna compile? Almost. We're almost there. malloc. Okay. stdlib. Device. Oh, because it's already a pointer. So printf. Let's actually make it fprintf and do std error. Okay, so here what we have to do, if we want to initialize the devices, we have to provide the callback, which means, by the way, that we probably have to do that in a plugin. I think that would make sense to do that in the plugin and store the device in there. Yeah, and go ahead and do that. Yes. So we go into the plugin, and in the plugin, what do we do? We just store. So we have a lot of sections in here. So this is just a visualizer responsible for visualizing things. We have a renderer which does FFmpeg stuff, and we have FFT analyzer. So I suppose we need to have like a microphone stuff related thing. Microphone. Yeah, it's gonna be just like a pointer like that. And in initializing of the plugin, what we're gonna do, we're gonna literally do microphone and just init audio devices, and we're gonna provide literally the callback. Yeah. So, and that should just work. And the thing we have to do, like, it's gonna greatly depend. We can already try to visualize whatever we get from the microphone. We should be able to try to do that. But we need to appropriately massage the UI code, because right now UI code isn't capable of doing any of that stuff. So our UI code looks like a decision tree, right? It looks like a big decision tree. When you start rendering the frame, we check in what state are we currently in. Are we in a preview state, or are we in a rendering state? A rendering with FFmpeg. And there is a huge condition in here that actually makes that decision. So let me show you how huge it is. Yeah. So that's the size of the condition that makes a decision. So this is a huge if with 2 branches. You either in preview mode, which you preview the thing, or you are in FFmpeg, right? And the size of this thing is not really that big. It's only 166 lines, right? It's not that big. Right? And yeah, so essentially there's only 2 like states in here. But within those states, there are some substates, right? For example, we decided, okay, we are in a preview mode. So, and in a preview mode, do you have music loaded? And if you don't have music loaded, we are displaying drag and drop music here, or couldn't load the file in case of an error, right? But if you have a music loaded, we are keep updating the music, we keep handling the special keys and stuff like that, and we keep visualizing. So it's a decision tree, right? We are in the preview mode. In the preview mode, do we have a music? We don't have a music. Have a music, don't have a music. Right, if we are not in the preview mode, we're in the FFmpeg rendering mode, and within that FFmpeg rendering mode, we have two situations. Is FFmpeg process running or not running? If in FFmpeg rendering mode, the FFmpeg process is not running, it's a FFmpeg failure. We just display that to the user and we wait until the user presses escape. If FFmpeg is running, we have another decision tree. Is it rendered everything, or the rendering was cancelled or not? If it was not cancelled, we just keep processing and send new frames. If it was cancelled, we try to finish it. And if we couldn't finish it, we set FFmpeg process to null, which effectively jumps to showing FFmpeg failure. Right. So there is a decision tree which decides what is shown in there. So it may look like a big thing, but it's actually rather easy to navigate. I even put some sort of a comments in here that describe what current state is. Right, so for example, we're in a preview mode. Okay, I don't care about the preview mode, I'm interested in a rendering mode. I jump to the corresponding curly brace. Any text editor, any modern text editor has a functionality of just jumping to the corresponding curly brace. I just skip that. Okay, we are in a rendering mode. Within the rendering mode, okay, here is the failed FFmpeg state. I don't care about that state, I skip that. Okay, FFmpeg process going, and I instantly found the place that I'm interested in, sort of like with binary search. Sort of like with the binary search. So I have this big decision tree, and I know different states of that decision tree, and with just a very basic functionality of the text editor, I can quickly find that state somewhere here. You could say that you could probably compress this code by factoring out these branches of if conditions to separate functions. And that is true, that would compress this code. But would it make it more readable? That's a very interesting question, because now you can read this thing top down quite easily, and you can skip top down with like corresponding curly braces very quickly. But if you factor out all these things to separate functions, now you have to jump between the call and the definition all the time to make sense of this entire thing. Here you have the entire structure in front of you. This approach is okay for very small state machine, right? It's rather small state machine. It's only 166 lines of code. When it gets bigger, I'll try to think making it I will try to think about making it smaller and more compact and like stuff like that. But until it's like that, it's kind of fine. It's kind of fine. Right. So yeah. We'll see how it goes. We'll see how it goes. Maybe in the future we're gonna have so many different states that we're gonna introduce some sort of like abstraction of a page, right? Just like, I think something like that exists in Android, I think. Right. It's a balance between readability and ease of change. Yeah, exactly. Right. While it's small, I think it's acceptable. When it becomes bigger, we can think about how to make it better. So, and what do we need to do? Essentially, we are in a preview mode. If we are in a preview mode, and music is not supplied, we are specifically waiting for somebody to drag and drop the music. And you know what's interesting? I think the drag and drop handling has to happen precisely in a place where we expect the thing to drag and drop, I think. Right. So essentially, yeah. We can literally do it here. I don't know why I didn't do it in here. That makes a lot of sense to actually put this entire stuff in here. So it's going to be 8 space, boom. There we go. So we are waiting for the user to do drag and drop. In that specific state, we can also check, as was suggested in the chat, is key pressed. So if you press key M, we can switch to the, what is it called? The recording mode. The recording mode. In the recording mode, we need to start the device. So we have a separate module for a mini audio. So we need the devices. start the device. Start the device, and we're gonna accept the void pointer of the device. Device. So separate and let's see. So in device in here, so the device has to be the pointer to my device. My device. I really like that. I'm sorry. I'm so freaking sorry. Anyway, so we have to do this thing. We're starting the device. We don't even have to take a pointer, and that should start actually like doing the thing. It should start doing the thing and calling the data callback and whatnot. So that means that in plug.c, what we do, we take P and we take a microphone and we start in the device, and we need to somehow indicate that we are in a different state. We need to somehow indicate that we're in a different state. So maybe in the plugin, we're going to have recording true, but I'm not sure if this thing is, this name is a good for that specifically. Right, so boolean recording. So initially it's going to be false, but then where's rendering? P render, yeah, there we go. So if you're not in the rendering, we're checking for music loaded, right? We're checking for music loaded. Otherwise, if P recording, right? So this is recording. So we're gonna first check for the recording. This is what we have to do. This is what we have to do. We don't have to update the music. We don't have to handle space. We don't have to handle Q. We don't have to handle F. But one of the things we have to do, we have to handle FFT analyzer and rendering. And believe it or not, I think that is literally it. Yes, because the callback that we call in there will already automatically supply data for the FFT analyzer. So the only thing we have to do, we have to just render it. Holy fucking shit. So that's it. Well, I mean, of course, it will require a little bit of a polish and you know, handling errors properly and logging them properly. Like we need to use a Raylib login and stuff like that. But ultimately, this is it, right? We also need to implement like actual recording and collecting. So yeah, that's really interesting. Okay, so let's try to compile this entire thing. So let's go to the compilation here. So in init audio devices, we need to include the separate translation unit for miniaudio. Right. So what else do we have in here? Start the device, conflicting types. Why are you telling me? Oh yeah, because of this scheiße. Okay, so can I just accept void in here? And yeah, I think I can pass void to any pointer. So the void star is a magical pointer. You can assign void star to any type of pointer and vice versa, right? So it's sort of like a generic pointer. So that should work, I think. So result is my result. What else do we have? So it has to be just the device. So we have to uninitialize it and return -3. Yeah, so I suppose this thing should return a boolean, and we should return false in this specific case and true in this case. And somewhere in the plug, start the device. If you couldn't start the device, you have to do something, but I don't want to do it right now. And there is no boolean, of course. So let's just include, include stdbool.h. Right, so there's a conflict in here, so this has to be boolean. Are you ready? Okay. Shut. I'm fucking scared, mate. I'm fucking scared because that's it. So that should be the integration with the audio, with the microphone. And I don't know if it's gonna work or not, right? So because there's nothing else left to do, right? So everything seems to be compiling. Yeah. Okay, let's go ahead and just like try to call this stuff. A little bit scared, a little bit nervous. Musializer. Okay, so if I press M, we should go into the mode where we receive all that. Yo! There is a low noise somewhere in the background for whatever fucking reason. Do you guys know what it is? Maybe it's just a background noise. Maybe it's like a fan. Yeah, it's probably a fan. We cannot hear it. Maybe table vibration or something. Yeah. That is so fucking cool. Yo! I'm just trying not to be too loud because it's a midnight. Ah, this is so fucking cool! Holy shit! And we managed to do that within 2 hours. Surprisingly, I didn't expect that. So yeah, that's so cool. I guess I'm gonna do the recording and rendering integration already off screen because it's basically just wiring up all of these things. It's basically just wiring up all of these things to FFmpeg and stuff like that. It's just like not that interesting, but yeah, we did it. We actually did it, chat. That's so cool. So yeah, all right. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session with Azuzin. Love you all. Mwah.